So, Madhvi, I think we can start the live streaming.
Yes, sir. Started.
Okay, so Rajendra, I think we can proceed.
Yeah. So just a minute. Okay, so let's start. Good morning, everyone. On behalf of INYAS INSA, I welcome all of you to this event on the Science Day celebration. This event is being organized jointly by INYAS and INSA since last few years. As you know, 28th February is a very special day for Indian science community because Professor C.V. Raman discovered Raman effect on 28th February 1928. And he was then awarded the Nobel Prize in 1930. Since then, we have been celebrating 28th February every year as a science day in all academic and scientific organizations in India. The aim of celebrating National Science Day is to spread a message about the importance of science in our daily life. We also discuss how to connect various developments in the field of science with new technology. In fact, I am happy to note that the theme of this year's National Science Day is to integrate science and technology for sustainable future, which is need of ours for the society. In this line, Raman scattering technique plays a big role in studying the physical properties of many technologically important materials for sustainable development. Being myself from physics background, I use Raman scattering extensively for my research. So on the occasion of this Science Day celebration, we are joined by Professor Chandrima Saha, President INSA, Dr. S Kiran Kumar, former Chairman ISRO, Professor D.V. Khakkar, Vice President INSA, and Dr. Chandrasekhar Sharma, immediate past chair of INYAS. I welcome you all, and on behalf of INYAS INSA, we especially welcome our guest, Dr. A.S. Kiran Kumar, for taking time out of his busy schedule and being with us on this special day. I also welcome fellows of INSA, INSA Secretariat, all INYAS colleagues, INYAS alumni colleagues, sponsors of INYAS National Awards, jury members, and all students who have joined this event. As this program is also being live streamed on our YouTube channel, let me also welcome all who have joined through our INYAS YouTube. Thank you all. Rajni, over to you.
Thank you, Rajendra, for presenting the welcome remarks. Like previous years, it is indeed a great pleasure for INYAS to organize National Science Day on this very special day, February 20th, on this virtual platform jointly with INSA. We are looking forward to the various addresses, keynote address by Dr. A.S. Kiran Kumar and addresses by President INSA and so on. On this occasion, INYAS National Awards for Research Excellence will also be announced along with short presentations by the awardees. And also we will be releasing INYAS newsletter in various regional languages. I thank one and all for coming here, and it's a great pleasure for me to anchor this program. I now request Professor Chandrima Saha, President INSA, to address the gathering.
Good morning to all, Professor Kiran Kumar, Professor Khakkar, other distinguished guests, all INYAS members, students, and friends. I know it is a very busy day for almost everyone today because it's a science day and we need to, attend to so many pleasant duties today. But I'm very happy that I could be here, and I'm deeply honored to have the opportunity to speak on the occasion. And this is the day when Dr. Raman discovered the Raman effect. And I'm thankful that INYAS have taken the initiative to celebrate this day. We do need to celebrate our discoveries, our role models, and the advances in science that we have made, so that progress that science makes is appreciated by one and all. On this day, I would like to speak to the young scientists of the country, many of whom have become inspiring models to members of the future generation. It is really a very happy occasion to say that I have seen the youngsters that I have seen very young are members of INYAS now, and they're contributing so well to science. And so my congratulations to all of them on this day. We as individuals and groups are fortunate to be doing science, as every day in our lives is a learning experience, and this continues throughout a scientist's lifetime. It is a privilege to be looking at the beauty of life and nature up close, and we are very fortunate to have this pleasure that many of our friends and colleagues may not be enjoying. People can be creative in any sphere of life, as we see with creative artists expressing the joy of living through expression of their concepts. But to be in science, you are creating knowledge that could be eventually useful for society. Like every piece of art has its value in enriching the human mind of both the creator and the observer himself or herself. The ideas created in science are also of great value and utility. We as scientists are also part of the society, and as a scientist grows and evolves within society, as a child, as a young person, the right ethical and moral values imbibed will eventually benefit science itself, and it will reflect in their work. What impact would a scientist like us would like to leave to the world apart from the science we do? The correct spirit of research can be transmitted to the next generation of scientists by practicing scientists themselves. So the young scientists, the older scientists, all of us should take an endeavor to do this. As a part of our journey in science, it is important for us to mentor our juniors and impart them with the essence of scientific practices. Our students should learn from us and should be empowered by what we teach them. They should then discover on their own, enriching from the knowledge we give them to make a difference. It should be appreciated that mentoring is an important part of our scientific journey. It is a rewarding experience for both the mentor and the mentee to evolve together as a part of the scientific community. Science provides a sense of wonder, not just by showing us what the world is about, but also that by science, we can reveal the world. Even though there is a great diversity of life on Earth, we humans consider ourselves very special. We transform our environment, we live in complex societies, we speak complex languages. We have existed over 1 million years, and science has existed as a dominant factor for about 400 years and as a source of economic technique for about 200 years. The applications of science are cultures too, and moral questions that scientists have about their work is about application as well. Science creates power as it generates knowledge and the influence to do things, but science does not give instructions about how good or bad this power is. An important aspect of science that has a problem in relation to society are actually the ideas and the techniques and not the applications per se. We have seen during this pandemic, and we have provided information to the public regarding various issues of science, but we have not really presented the process by which the science works. This is of utmost importance, as then people around us will appreciate how scientific discoveries eventually become useful for the betterment of society. The very complex challenges facing us today can only be tackled by our endeavors to look for new innovation. We know that history teaches us how scientific discovery has revolutionized life on Earth, and serendipitous events like accidents, mistakes, and luck have led to major discoveries. Perhaps the most recognizable one is Alexander Fleming's discovery of penicillin in 1928, for which he was awarded the Nobel Prize in 1945. This discovery transformed medicine and saved people who could die out of a simple cut in the hand or elsewhere. To face the challenges, we also need to communicate. It is the key science enabling the global science. We have to speak, we have to communicate. So it is actually a key enabling the global solutions to complex problems. The language, the storytelling, the education are key bridging gaps between scientists and the society. And scientific knowledge becomes powerful when it is communicated well. We have to recognize the importance of social, cultural, and political implications and the use of our language to get across important messages. We have to support the UN Sustainable Development Goals through our innovative research and communication. I would like to tell the younger scientists that along the way, pressure of an academic career may bog you down, because scientific creativity is very competitive and your energy will be drawn to that. But as you tinker with ideas, you develop your skill, and we know that discovery favors a prepared mind. So it is essential to have a deep insight into the problems that you address, because that is what it is all about. You have to take care of life for the future. We have catastrophic consequences of our climate due to our own inappropriate activities. Global climate change has already had observable effects on the environment. Glaciers have melted, ice on rivers and lakes is breaking up earlier than usual. Plant and animal ranges have shifted, and flowering of trees have changed their times. Population of many animals and plants have dwindled. Biodiversity is threatened. Global temperatures will continue to rise for decades to come, largely due to greenhouse gases produced by human activities. Scientists forecast a temperature rise of 2.5 to 10 degrees Celsius, 10 degrees Fahrenheit over the next century. Sea levels are going to rise, hurricanes are going to increase, precipitation is going to change, and conditions will be difficult. For all the young people, you have a difficult world to face eventually. Emerging new diseases are going to hit us, and we need to be prepared. So it is up to the younger generation, whichever field they are, and especially if they're in science, to make the world a better living place through their action, to restrict the changes that are occurring and improve the kind of life that we lead by investing in green energy and by reducing harmful emissions. Also, a considerable amount of work needs to be done in the microbiological work to avoid, we cannot altogether avoid, but the emerging diseases will be keeping on coming, but we should be prepared for that. More research is needed for encountering the emerging pathogens. And that is one very important goal that science should have today. Lastly, we urgently need a science that recognizes the fundamental interdependence of all natural phenomena, and it reconnects with the earth where we live, a connection that we seem to be losing. So it is my plea to the younger generation to carry on their work with utmost sincerity, with all ethical standards built in, that they should contribute to how the world is going to look tomorrow. Thank you very much.
Thank you very much, Professor Saha, for your inspiring words and also for highlighting the opportunities and responsibilities young scientists have. Thank you very much for your address. I now request our chair, Dr. Rajendra Dhaka, to introduce the plenary speaker.
Thank you, Rajni. It is my great pleasure to introduce our plenary speaker, Dr. S Kiran Kumar, to our audience. Dr. Kiran Kumar is an Indian space scientist and former chairman of ISRO from 2015 to 2018. Dr. Kiran Kumar also served as director of Ahmedabad Space Application Center. He has credited with development of Chandrayaan-1 and Mangalyaan spacecrafts. Dr. Kiran Kumar has received many awards and honors. In 2014, he was awarded the Padam Shri, which is India's fourth highest civilian award, and this was for his contribution to the field of science and technology. In 2017, he was awarded with the Vijnan Ratna H.K. Firodia Award for his direction of the Indian space program. And in 2019, he was honored with France's highest civilian award for his contribution to India and France space cooperation. With this brief introduction, I request Dr. Kiran Kumar to deliver the public lecture. Over to you, sir.
Thank you, Rajendra. And at the outset, on this occasion of the Science Day, it's indeed a great privilege and honor to be part of the program that the Young Scientists Association is carrying on. And thank you very much for this opportunity. And what I intend to do today is take you through the journey of Indian space program, and through that look at how India has dealt with an emerging technology and how it has utilized, and try and look for, are there any lessons in this for us in the future? So in fact, before I start, I also remember having the privilege of listening to Dr. Sir C.V. Raman in Raman Institute when I was a student in the National College Physics Honors, where Dr. Raman explained to us the intricacies of percussion instruments and the mathematics involved in that. So it was a great privilege way back in the 70s. So if you look at in terms of the space technology itself, we had a very great pioneering scientist, young scientist by the standards that we are talking of today at that time. And he looked at availability of a new technology of space when Russians put their first object into space way back in 1957. And at that time, he was looking at how we can make use of an emerging technology. He had said, our national goals involve leapfrogging from a state of economic backwardness and social disabilities, attempting to achieve in a few decades a change which has historically taken centuries in other lands. This involves innovation at all levels. And then what he did was he conceived of utilizing the space technology for national development and making it happen through capability demonstration and then capacity building. And through capacity building, meet the national, societal, and strategic needs, and also become a significant player in space economy. These are all the thought processes he had in mind. And how did he begin the whole activity? He could convince his friends in America, Russia, France, and Germany that conducting an upper atmospheric research in a unique place we have near Tumba, where we have a geomagnetic equator, and at that place, if we fly sounding rockets and conduct research in the upper atmosphere, it will be beneficial for the entire scientific community. And with that, he could bring sounding rockets in the form of kits. And the church building, what you are seeing here, is the place where the first assemblies of the sounding rockets were done, and it was launched. And one of the key things he did at that time was, of course, trying to make sure that we build capability in the country by collaborating and conducting unique experiments. And if you look at in communication, India conducted the world's largest socio-technological experiment by borrowing a satellite from America. At that time, they were building one of the very advanced technology satellite. And for the first time, using a geostationary platform, broadcasting was being attempted. And if you look at India at that time, in the early 70s, only 4 metros had the privilege of looking at television programs. And what Dr. Sarabhai did was convincing Americans that they should allow us to borrow their satellite and move it over to the Indian longitude for a year. And in about 2,400 villages, conduct an experiment. And again, making use of a Franco-German satellite, conducting some experiments in communication area and sounding rockets, bringing them in the form of kits, assembling and giving them hands-on experience. And again, Professor Pisharati conducted an experiment in Kerala to demonstrate how coconut root wilt disease can be actually looked at from an aircraft by flying a Hasselblad camera borrowed from NASA and showcasing that how the coconut plantation diseases could be identified. Then balloon experiments where cameras were flown on the balloons and aircrafts. All these activities were done in sequence. And satellite instructional television experiment, which I talked about, was a very unique experiment. And it was here that actually Dr. Sarabhai's vision demonstrated how making use of a technology which is available, which is accessible to you, can be used, and you can conceive of solutions which are very specific to your country, and in that process make a difference to the growth in the country. In fact, you can imagine in 1957, India was just 10 years after independence and struggling with the resources, both in terms of solving the issues of development, poverty, education. And he made sure that linking about 2 lakh people in 2000 remote villages of the country using one of the most advanced technologies of satellite, and then building the entire gamut of the system which receives the signal from this broadcasted satellite and provide it on ground through a mechanism called direct to community sets, which became actually a forerunner for direct to home television, which we are all familiar today. And the complete hardware for that, using the black and white television sets of ECIL, and then the front end hardware was all realized in the country. And what this demonstrated was actually bringing in Ministry of Education and NCERT and linking the entire these 2,400 villages. It demonstrated how instructional program on agriculture, primary education, teacher training, and the issues of involving social scientists, economists was all done. A large experiment conducted by making use of an emerging technology of space at that point in time. And having demonstrated in 75 the uses of communication broadcasting, India went ahead with an INSAT series where the first generation was built. Again, the type of satellite that was conceived was one of its kind. And at that point of time, nobody had attempted providing communication, broadcasting, and meteorology all in one single satellite. And India had to resort to it because of the resources and the requirements of 3 separate satellites and separate launches would have been more consuming more resources. And then after INSAT 1 series, the complete set of INSAT 2 series onwards, India is developing its own satellites and the communication system. And gradually things have been growing and making use of these technological capabilities to demonstrate applications in different areas. Much before the telemedicine of today, what you are seeing through the terrestrial network, in the early years using these satellite technology, it was possible to link Andaman and Nicobars with the super specialty hospitals, and then tele-education providing to primary and secondary schools, and also to engineering. The linking through tele-education systems was done. And then another major actually facilitation that happened during using the space technology was the ability to actually track cyclones and provide predictions well ahead of cyclone hitting the 7,500 kilometer long coastline of India. And today, by virtue of this, both inundation maps of floods and cyclones, flood hazard zonation, flood forecasting, all these activities have become regular, and national database for emergency management and establishing integrated control room for emergency response and enhanced support to international charter have all become a routine. And disaster management support, not only by providing observations from space in different wavelengths and different frequencies, generating technology for monitoring from ground, whether it is weather radars or the profilers, and then automatic weather stations, and a host of such technological capability has been built in the country. And for using both for floods, cyclone and extreme weather, forest fire, drought monitoring, landslide, all of these activities get support from what is being done, both in terms of technology from space and ground. And in fact, this is another very interesting story where what Dr. Sarabhai had envisioned and what Dr. Sarabhai had to actually convince the fishermen in that Tumba to help let them conduct our first sounding rocket experiments. And in fact, for that, he had to convince the fishermen through the help of the Reverend Father Peter Bernard at that place, and telling the fishermen, if you vacate this place and allow us to conduct experiment, one day in future, the country will benefit. Just as though to demonstrate this, what happened is 1999 onwards, India was able to provide through its satellite observations, looking at the color of the ocean in 8 different wavelengths and the thermal fronts, identifying chlorophyll, and through that, through the food chain of the fish, tell the fisherman about the specific location where in the ocean he can go and do his fishing. And this information was being disseminated through the prospective fishing zone map through an entity called Indian National Center for Ocean Information System at Hyderabad. And to this, we added a new capability when we brought in our navigation satellite. Today, a small gadget, which is battery operated, can be fitted into the boat of the fisherman. And when he is in the ocean, using a mobile in his hands, the mobile itself does not have any connectivity to terrestrial tower, but this mobile is linked to the gadget fitted in the boat. And through an app in the mobile, in his mother tongue, he gets specific information about the weather vagaries, and also as a video compass, it directs him to the prospective fishing zone. And then if he is approaching international boundaries, it showcases to him, gives him an alert. So you can see here, a person who does not know reading or writing is getting the advantage of the most advanced technology of rockets, satellite, and instruments on the satellite, communication, navigation, all of them put together, it has provided him. And today, more and more state governments are providing such gadgets to the fishermen across the coastline. And then navigation itself, India developed its own navigation series. Both Gagan was making use of the GPS system, where Indian subcontinent, for any aircraft flying over the region, this scheme provides safety of life and integrity of signal, a safety of life assured signal available to a receiver, which helps it planning the en route travel for aircraft and also for precision landing. And our own navigation satellite with a very innovative approach of making use of only 7 satellite constellation in comparison with what America, Russia, China, and Europe have done of 24 to 32 satellite constellation. So again, here you can see the innovation of making use of a very novel concept of putting geostationary satellites and achieving. Today, by virtue of having space technology inputs in optical, microwave, multispectral, and multi-temporal data, along with navigation-enabled positioning system and data collection using mobile platforms, digital elevation model data generated from our own data sets, and using modeling techniques and using a suite of applications countries is benefited from in working on socio-economic security, sustainable development, and governance in all these activities. And linking the developed information and data sets along with the government entities becomes very important when you want to transfer the use of technology for practical applications. And National Natural Resources Management System, which was conceived to link the various state and central government agencies. And then there were early adopters of technology. Early adopters like Forest Survey of India started providing biennial state of forest, Ministry of Earth Sciences using it for potential fishing zone advisory, which helped in reducing the search time, increasing catch, and increasing the net profit for the fishermen. Civil aviation, making use of Airports Authority of India started building this system. Then Ministry of Earth Sciences, which actually provides all the cyclone and weather forecasting related things. And Ministry of Agriculture, which has actually adopted the space-based technology inputs for actually forecasting for 11 crops and also for drought assessment and various other activities. And actually what happened is the Honorable Prime Minister also had extensively utilized the communication and remote sensing technology when he was Chief Minister of Gujarat, and later when he became the Prime Minister. He made sure that more and more people in the governance actually are exposed to the advances and the technological capability that India has built in this area. And a program was conducted where large number of secretaries across the state and centers were brought together. And in that occasion, even Prime Minister himself spoke extempore for 45 minutes, telling the secretaries how space technology can be used in various activities that the governance conducts. And as a result of that, the usage significantly improved. And then actually today, based on the space technology based information, land use, land cover maps on a regular basis, it is generated. 17th cycle of that creation of data is in progress. Forest cover, wasteland mapping, all these activities are happening on a regular basis. And then if you look at using this technology for geospatial support for governance, you're familiar that integrated watershed management, where surface water map every few days it gets generated based on satellite data. Then in city planning, whether it's in the way more than 239 cities, where using the geospatial information, the planning and implementation activities happen. Manrega, which is one of the flagship programs of the governments all along, actually the geospatial technology provides an excellent opportunity not only to keep track of how things are happening and also for planning for future activities. And then using in agriculture itself, if you look at for forecasting the yield of the major crops or identifying drought affected areas, crop insurance activity, horticulture, sericulture, all these things are actually being provided with enough information base from the satellite. While all these activities happen, India also established its own capability to look at going beyond Earth and also looking at space from space, looking at Moon and Mars. And in this, the space science program itself, if you look at starting from sounding rockets, Aryabhatta carried some, they actually X-ray experiments, and then gradually building capability with X-ray astronomy, solar X-ray spectroscopy. Chandrayaan-1, then Mars Orbiter mission, AstroSat, and Chandrayaan-2. And in future, Chandrayaan-3, Aditya, etc. are all planned. And these are the missions that are going to go ahead. And if you look at Mars as a mission, while it was actually a mission meant for about, originally planned for 6 months, it has already completed 7 years. And even recently, using this Mars satellite data, studying about the solar coronal sphere has also been demonstrated, showcasing that newer and newer applications are possible of the capabilities that have been built. AstroSat mission is again a very unique mission where India provided virgin data to our own scientists, and this is the first observatory provided by Indian space program, and it is unique because it has got a multi-wavelength capability, first of its kind, and already provided tremendous opportunity for scientists in the country. More than 200 odd publications have happened, and one of the key things is it for the first time looked at in the specific region of the deep space signal coming from 9.3 billion light years away, and in a region where this was detected for the first time because the telescope, far ultraviolet telescope carried on AstroSat, has the highest angular resolution and maximum sensitivity, and as a result of that, this unique observation was possible. And then India also collaborated with other space agencies, with France, etc., for megatropics, providing information for the humidity sounder, the data of which goes into our numerical weather forecasting models, the whether it's the sea surface heights and monitoring various sea parameters, the activities are done. And true to its tradition, India also has demonstrated that this technological capability is also beneficial for the neighboring countries. The knowledge you acquire and the skills you acquire should be for the benefit of global community, and our neighboring countries are being provided this transponder capacity by India. And then as the technological capability started growing, India is also now trying to look at taking Gagannauts and orbiting them around and bringing back. And this actually originally was planned for the before the 75th anniversary of Indian independence, but due to COVID and other issues, there is a delay in this program. But primarily, this is looking at providing India a capability to put humans into space for future activities. And what this does is it brings in a huge amount of science and technology challenges, and across the disciplines in the country, the activities are going to get energized, providing more opportunities both for scientific endeavors and also for engineering and technology. And this just lists a set of those activities for which this program is going to be supportive of. And for doing all this, the technology was developed in the country, starting in the communication satellite. What India did was make use of every opportunity provided. For example, Apple was an opportunity grasped when Ariane, in their initial years of launch vehicle development, offered to launch a satellite free. So we built a 3-axis stabilized communication satellite way back in '81, and then INSAT-1, which was actually a first of its kind 3-in-1 satellite conceived but launched from outside and also built outside. But INSAT-2 onwards, progressively the systems are built in the country, bringing in the technological capabilities. Today, high throughput satellites, which are going to provide very large broadband connectivity to the rural areas, gram panchayats, etc., more than 6,500 gram panchayats, connectivity to that, these satellites are getting developed. Meteorological satellites, here again, India not only made use of its capability for providing weather information to our own community, but also using satellites like OceanSat-1 and 2, where the microwave sensors, scatterometers provide ocean wind vector information, which is fed to the numerical weather forecasting models of the global community. And then in Earth observation, again, starting with Bhaskara 1 and 2, which were again an opportunity taken when the Russians offered to launch 2 satellites for us. And then starting with that, continuously developing the technological capability. And between 95 and 99, India had the privilege of having the highest spatial resolution imaging in the civilian domain. And today we have a capability to look at the global regions and also Indian regions few times a second in different resolutions from 1 kilometer to sub-meter, few seconds, few times a second to large intervals, and then carrying out these observations in different wavelengths, finer and finer wavelengths is all part of the development that has happened. While we are all clear that when looking from space during the monsoon period of June to September, cloud cover affects observation, but microwave penetrates through the cloud and you can observe things from microwave, and India has developed this capability of using microwave. Like I said, scatterometer provides ocean wind vector information, which we share with the global community. And just a few days back, we had the C-band synthetic aperture radar, which was launched second one after 10 years. And then we also have X-band SAR, which is operating in inclined orbits for many applications. And for doing all this, the technological capability of launch vehicle, starting from sounding rockets, was gradually built up. And today we have a polar satellite launch vehicle, which has done more than 50 launches successfully and has done Chandrayaan mission, Mars mission, and also 104 satellites in one go. And just a few days back, it launched the RISAT-1A. And it has got a unique capability of putting satellites, multiple satellites into orbit, and also satellites into multiple orbits. And then if you look at geostationary satellite, where the cryogenic engine technology was completely indigenously developed, and today we have a capability which is being enhanced to put humans into space. For doing all this, you have to build technological capability of test facilities and simulations, etc. And if you look at the whole concept, leapfrogging, what was talked about by Dr. Sarabhai, it is while you make use of the technology that is accessible to you, and what is not accessible you build, and also conceive of solutions to the problems you are facing by what technology can provide, and through this process take things forward. And if you see right from sight, and then like I said, highest civilian resolution imaging system, Mars orbiter using the limited launch capability that existed, AstroSat, and then 104 satellites in one go. All of this demonstrate that an emerging technology in the late 50s, a technology of going to space, putting things in the orbiting platform, and through them looking at ground and looking at space, providing an opportunity of developing the technology and finding solution to the various problems has been demonstrated using the space technology in the country. But then if you look at space today, the international collaboration, space for common good, whether it's United Nations, Outer Space Entity, or Committee on Earth Observation Satellite, World Meteorological Organization, the CGMS, all of them work together and then bring in this technological capability for the benefit of the society. But then things are moving ahead. While we are building all these capabilities, world is moving ahead. And while the space age started with Cold War, and again, today we are seeing a change of scenario, and again, war is already happening, another war. And space is being used not only for providing better capabilities on Earth, but also looking at providing opportunities for space exploration, strategic applications, tourism, space habitats, all of these things are moving ahead. And today, more than 40 nations are engaged in full-fledged space activities. More than 100 nations are utilizing these space systems and services. Space for national development in particular, and for the benefit of entire humanity in general, on the basis of freedom of exploration, freedom of access to and use of outer space, freedom from threats to space systems and infrastructure. While in the initial years, it's only the national governments which were running space program. Today, the monopoly of nation states in running space has already been challenged, and it is this private enterprise which is moving ahead rapidly and then providing solutions. So, and if you look at what the space economy states, that as commercialization of space is upon us, the world's fascination with space spurs increasing investment and drives activity in launches and satellites sent into orbit. Today, people are already bringing in thousands of satellites into orbit, and as a result of that, many problems and issues are also cropping up. But then, if you look at the issue that we wanted to talk about, harnessing and emerging technologies, there a lesson in India's space efforts. If you look at what India did, it tried to look at a new technology which was coming up, and there were people who could visualize the benefits of that and convince the people who mattered to put in efforts, and through that process gradually build in a certain capability. But still, what capability that has been built is inadequate, and you need more capacity, and more capacity if it is needed. It's also the economic strength that determines whether you are able to do that or not. But today, if you look at the problems of human life on Earth itself, while one deals with the issues of survival, food, shelter, health, and then dealing with nature's fury, or even dealing with man-made disasters, including whether it is though there is a doubt whether the pandemic itself was a natural disaster or man-made disaster, but in any way, it was a huge disaster which humanity had to face with. And then comprehending the universe itself. In addition to that, dominance of one group over the other group, which leads to the very conflicting situation, and one such situation which we are facing even today. And then emerging technologies, if you look at in a Wikipedia definition, emerging technologies are technologies whose development, practical applications are still largely unrealized, but they are figuratively emerging into prominence from a background of non-existence or obscurity. And if you look at 10 emerging technologies of 21, they said it is decarbonization, crops that self-fertilizer, breath sensors for diagnosing diseases, on-demand drug manufacture, energy from wireless signals, engineering better aging, green ammonia, biomarker devices, etc. And also if you look at 2022 versions, it is metaverse, self-fertilizing crops, 3D printed houses, low carbon shipping, cryptocurrencies, and then self-fertilizing crops are among the top 10 emerging technologies. So like this, of course, if you keep looking, then in metaverse, what is said is it is basically a virtual world created by combining different technologies, including virtual and augmented reality. So if you look at the scenario in India itself, while in the industrial revolution occurred, what happened is the raw material in the country probably was taken advantage of by those who could actually manipulate and run the globe. But gradually, as things evolved and India started developing, today there is still one very dominant, you can say, manipulation that is happening, that is making use of the Indian intellectual capability and building capabilities for monitor, not only controlling or doing things. If you look at today artificial intelligence or machine learning or all these areas where these huge enterprises globally which have the reach, because what the technology of communication and transportation has done, it has brought in the hands of individuals across the globe information. Through this process, the changes that are taking place globally, we also run the risk of actually being manipulated and utilized, because the intrinsic ability to invest, generate more resources, and make use of the technological and other capabilities that we are building in the building, utilize for our own benefit. This is one of the key problems that we are facing today as science and technology grapples with problems of sustainability on life, on planet, sustainability of life on planet Earth. As a country, we also face this exploitation of intellectual capability by those who have already established infrastructure and those who are continuing to look at this as a mechanism. These are the challenges for us, and I'm very certain that the younger generation is actually grappling with these problems, and they will find solutions both to the problems of our country, but also to the problems of the humanity at large. Thank you very much for giving me an opportunity to speak about an emerging technology, how much utilization India could do, where it is today, and is there a lesson for us for tomorrow. Thank you very much.
Thank you very much, Dr. Kiran Kumar, for giving us this evolution of Indian space programs and the current status and what are the challenges. We have a little time for questions. We have one question from Nalini Krishna. How are we dealing with the space debris, space junk? How does that affect future missions?
Yeah, space debris and space junk is a problem which is growing significantly, particularly because unlike in the yesteryears, today the number of satellites that is being put into orbit, the numbers are increasing very drastically. Just in last 1 year itself, the number of satellites that went in is almost 90% of all satellites that have gone up to now. But then people are also looking at 40,000 satellite constellation for providing internet capability across the globe. Not only that, the debris which gets generated when some collision occurs, intentional or unintentional, what is called as Kessler syndrome, where any object which is in space, because of its huge momentum, even few centimeters size object can result in collision impact, creating more debris. Now, what is being done is things are being looked at. How can these debris material be scavenged? And then there are ways how we can convert these scavenged material into resources for future, or bringing them back to Earth, or even looking at providing an opportunity provisions in the system where before the end of life of the satellite happens, they are brought to an orbit where they decay very fast and enter into the Earth's atmosphere. Today, the mechanism that exists is geostationary orbits are put into what is called as graveyard orbits. At the end of their functional life, they are pushed up and then they vacate the place for geostationary orbits. Lower Earth orbits, all the new satellites that are being launched are mandated to carry some provision where at the end of their functional life, they bring down the orbit and then bring it down to entering into Earth's atmosphere. Beyond that, there are companies which have started looking at service. That means you task them, they'll go into space, capture this, service it, or bring it back. Of course, only when the economy of doing things become sustainable, it will become a reality. But till that time, it's R&D that will be going on.
Thank you, sir. Our next question is from Dr. Chirashri. Are indigenously developed MEMS-based microsensors used in today's miniaturized satellites?
Today, miniaturized satellite, lot of MEMS-based equipment go into that. And even in India, for example, we have Semiconductors Laboratory, which is building MEMS-based sensors and also processors. And it's also actually developing MEMS-based sensing systems. Even in Indian Institute of Science, there's work going on in that. Today, there are not only sensors, miniature actuators, which are becoming for actually pico satellites, where carry these MEMS-based actually thrusting systems. Very small thrust can be generated using those MEMS-based systems. They are being actually experimented right now. They are not in any operational use, but experimentally they are being used.
Thank you, sir. How this technique is being used in cloud seeding? What would be its impact on cloud seeding?
Cloud seeding as such, I'm not very much aware of, because the cloud seeding is an activity which is carried out by flying on aircraft, some chemicals and putting the chemicals onto the clouds and then making the precipitation happen. And then, but using space technology is not there, but probably using aircrafts and drones, these are going to be possible for even more and more localized areas.
Thank you, sir. What are your views on space tourism?
Space tourism, like human nature, people want to experience newer and newer things. See, like when somebody asked, why do you want to climb Mount Everest? The person said, I want to climb it because it is there. So same way, you see moon, people wanted to go to moon. So same way, tourism is actually an experience which people want to feel and go. And towards this, already the enterprise is providing capabilities, and space tourism is already a reality. And in the coming years, or if not in decades, it's going to be feasible at lower and lower cost. Today, maybe something like 200 to 250K is required, but then it's all going to come down to maybe $50,000 to $50,000 or $10,000 is a reality. So it's going to happen, and it's already happening.
Thank you very much, sir. One last question. The cost of satellite imagery were very high till very recently, and it is in your leadership that had brought down and allowed a lot of academia also to be able to afford and do satellite image analysis and processing for various applications. I just want your opinion on what do you think is satellite imagery used for its full potential, or how much do you think one has to push it further still? And that will be the
today, for example, if you look at satellite imagery, the whole availability of the entire globe on a day like Planet Labs, and then with the large number of communication satellite coming, what's also likely to happen is all these satellites also will carry miniaturized and micro miniature cameras. And then the days will not be far when you know what is happening at any given location almost on a continuous basis. So it's only the matter of time before such thing happen. But then still utilizing this imaging or other various information picked up from space, what all could be done is actually growing at such a fast pace that it is only the ingenuity of the individuals in perceiving what kind of applications we can generate from this database that is actually limiting us. And I'm pretty certain it varies. While higher and higher resolutions are becoming possible with drones, the complete monitoring of the Earth in various spectrum, various electromagnetic radiation is going to happen, because the number of satellites that are going to look at Earth is already becoming in hundreds of thousands. So which provides a tremendous opportunity. And I'm sure people are already visualizing how we can make use of that data and bring in solutions to the problems that we are facing.
Thank you very much, sir. Thank you very much for your very informative talk and also for this very active discussion. We look forward to more occasions to interact with you. I now welcome Dr. Chandrasekhar Sharma, our immediate past chair of INYAS, for announcing winners of INYAS National Awards. Dr. Sharma.
Thanks, Rajni. So let me just share the screen. So it's an honor for me to announce the National Award for Research Excellence for 2021. So INYAS started these National Awards last year to encourage the excellence among the research students, PhD graduates. And last year we had these awards in 3 categories. And this year we are happy to announce these awards for additional 2, so total 5 categories. So let me just give you a very brief that we have received 7 applications in the category of best PhD thesis in natural nanofibers for societal impact. Out of that, 3 were shortlisted for the final round. In the category best PhD thesis in carbon nanomaterials, we have received 29 applications throughout the country, and we have 4 finalists for this category.
Chandra, sorry to interrupt you. Your slides are not moving.
Okay. Let me share it again. You can see it now? Yeah.
Yes.
Then in the excellence in nano innovation category, we have received 19 applications from freshly graduate PhD graduates, and we have 6 finalists in this category. And in the best PhD thesis in electrochemistry, we have received 34 applications, out of which 6 finalists were chosen for the presentation. And in the last Sir John Mason interdisciplinary research category, we have received 19 applications, out of which 9 applications were shortlisted for the final round. So we have made a jury for the initial shortlisting as well as the final round. And this jury was made of very highly eminent researchers comprising INYAS members, INYAS alumni, and the external members, and also from the industry. So we duly acknowledge our jury members who are listed here for their help and support in evaluating all the applications and finally choosing the winners, which will be announced shortly now unanimously. So with this, now it's time to announce the national awards for research excellence. So the first category is the best PhD thesis in carbon nanomaterials. And here, award is given jointly to, let's congratulate Dr. Aarti Gopal Krishnan from Indian Institute of Technology, Hyderabad. This award is jointly given to Dr. Aarti as well as Dr. Sarigamala Kartik Kiran from IIT Bombay. Congratulations to Dr. Aarti and Dr. Kartik. Next award is Best PhD Thesis in Electrochemistry, which is sponsored by Metrohum India Private Limited. And the award, again, in this category, we have joint winners, Dr. Shikha Khandelwal from Indian Institute of Technology, Gandhinagar, jointly with Dr. Sahil Thereja from Indian Institute of Technology, Roorkee. Congratulations to Dr. Sahil and Dr. Shikha Khandelwal. Next category is Best PhD Thesis in Interdisciplinary Research. This award was sponsored by Mr. Sivaraman Kraikudi. And this award is mainly focused for the students who are graduated from the universities. And the award goes to Dr. Nalini K. from Cochin University of Science and Technology. Congratulations, Dr. Nalini. We have next award, Excellence in Nano Innovation, which is sponsored by Dr. Sandeep Patil from eSpin Nanotech Private Limited. And this year, this award is given jointly to Dr. Manas Ranjan Panda from IIT Bombay, and Dr. Nitish M. Nair from IIT Madras. Congratulations to Dr. Nitish and Dr. Manas Panda. The fifth category, which is the last in this award, Best Research in Nanofibers with Societal Impact. And this award is sponsored by Dr. Mudrika from Cellulose Group, IIT Hyderabad. And the award goes to Dr. Soumya Selvaraj from CSIR CLRI Chennai. Congratulations to Dr. Soumya for winning this award. With this, I again acknowledge all the sponsors and all the applicants who have shown interest in applying for these awards. And I'm sure that these awards will further motivate our PhD students to continue the excellence in their research. Now, I think we can have the very short presentation from our awardees.
I am sharing the screen now.
Very good morning to one and all. I'm Soumya Selvaraj from CSIR CLRI. I'm here to present my work titled Role of Fibrous Protein Nanofibers in Acute and Chronic Wound Care Management. Skin, due to its protective nature, is constantly exposed to injuries from the external environment. Once skin is damaged due to an injury, a multi-cascade event is initiated, which is known as wound healing. It consists of multiple phases, and the important phases are inflammation, proliferation, and remodeling. During the inflammatory phase, neutrophils produces the reactive oxygen species and proteases to remove the devitalized tissue and also to prevent the contamination of microorganisms at the wound site. Later, cells like fibroblasts arrive at the wound site to initiate the proliferative phase. Fibroblasts are the crucial cells in the process because they produce collagen and glycosaminoglycans for the formation of granulation tissue, which is subsequently remodeled into mature dermis. During the inflammation phase, these neutrophils show increased expression of NADPH oxidase 2, which in turn raises the amount of reactive oxygen species at the wound site. And these excessive ROS damages the fibroblast, thereby delaying the healing process. Antioxidants can remove the deleterious effects of these reactive oxygen species, and increasing the local concentration of antioxidants at the wound site can accelerate the healing process. So the objective of my study is to incorporate natural plant-based antioxidants in fibrous protein nanofibers to prepare wound dressings for treating the acute and chronic wounds, especially diabetic wounds. Diabetic foot ulcer is known as the infection, ulceration, or destruction of tissues of the foot in DM patients. And out of 62 million DM cases in India, 25% develops a diabetic foot ulcer, which leads to around 1 lakh leg amputations per year. It leads to repeated hospital stays, permanent disability, and also have profound socio-economic impact. So we decided to fabricate silk-fibroin fenugreek nanofibers to enhance the healing process. The antioxidant chosen for the study is fenugreek, which is obtained from the plant Trigonella phonoglycium. Silk-fibroin is a fibrous protein which has excellent mechanical strength and a good biocompatibility as well. And during wound healing, it is known to promote hemostasis, and it is known to promote the migration of fibroblasts. So we prepared collagen and we prepared fenugreek and silk-fibroin nanofibers by co-electrospinning process. Then we tested the efficiency of healing efficiency of these nanofibers in vivo animal models. So after electrospinning, the nanofibers were subjected to thermal analysis, and they were found to be smooth, uniform, and randomly oriented. And the antioxidant property of the nanofibers was evaluated using DPPH scanning efficiency, and at 1:1 silk and fenugreek concentrations, the nanofibers were found to have around 48% of a DPPH scanning efficiency, and the fibroblasts showed great adhesion and proliferation over the surface of nanofibers. And from the in vivo wound healing studies, it was found that on day 12, around 97% of wound closure was absorbed for fibroin fenugreek nanofibers treated group when compared to the other two groups. And from the histopathological analysis, it was found that on day 8, lesser inflammation was observed in fibroin fenugreek nanofibers treated group when compared to the other two groups. And from the mass and trichrome staining, it was observed that on day 8, collagen deposition is only found in fibroin fenugreek nanofibers treated group, which was not there in the other two groups. And from this findings, it was proven that the prepared nanofibers enhance the wound healing by minimizing the inflammation and also by enhancing the collagen deposition. And to further improve the efficiency of these prepared nanofiber wound dressings, we have added collagen. Collagen plays a major role in all the three phases of wound healing, and addition of collagen in the nanofibers can provide structural and functional resemblance to that of the native collagen in the skin, and that which can further improve the healing process. So we prepared collagen cell fibroin fenugreek nanofibers by co-electrospinning method, and then we evaluated their potential in healing potential in diabetic rat model. It was found that on day 16, collagen cell fibroin fenugreek nanofibers treated group showed around 96% of wound closure, which is higher when compared to the other two groups. And on day 21, complete wound closure was observed for collagen cell fibroin fenugreek nanofibers treated group when compared to the other two groups. And from the histopathological analysis, it was found that on day 8, very lesser inflammation is observed in collagen cell fibroin fenugreek nanofibers treated group when compared to the other two groups. And on day 16, formation of well-developed dermis and complete epidermis has been observed in the collagen cell fibroin fenugreek nanofibers treated group with the formation of adnexal structures like keratinized layer and hair follicles. And these things were not prominent in the other two groups. So thus our prepared nanofibers enhanced the wound healing by minimizing the inflammation and by promoting the early reepithelialization and also by enhancing the collagen deposition. And overall, our prepared nanofibers enhance the wound healing in normal and diabetic rats due to the bioactive properties of cell fibroin and also due to the antioxidant properties of fenugreek and due to the biocompatibility properties of collagen and also due to the nanoscale topography of the scaffold, which enhances the cellular activities like cell adhesion and proliferation. So these are the significant outcomes of our work. And I would like to thank INYAS for providing me the great opportunity to present my work in front of this eminent forum. And I would also like to thank the Department of Biotechnology and CSIR India for the financial support. Thank you, Honorable.
Hello everyone, I'm Dr. Arthika Krishnan. I would like to first thank INYAS team for selecting my thesis for the award. My thesis was titled on sustainable synthesis of heteroatom both porous carbon nanosheets for high performance supercapacitor application. So why under the joint PhD program between IIT Hyderabad and Swinburne University of Technology? So why did you choose supercapacitors? So from the comparison of energy storage devices available here, this diagonal plot shows that the supercapacitor fills the gap between a conventional capacitor and a traditional battery. Further, the supercapacitor has several advantages over batteries, but still it has a major limitation of low energy density. So this major limitation needs much attention and improvement. Based on the mechanism of charge storage, it is basically divided into electrical double layer mechanism and a pseudocapacitor mechanism. So the pseudocapacitor works on surface redox reaction and EDLC works on the electrical double layer mechanism, which is adsorbed charge storage at the electrolyte interface. So how does this EDLC works? And EDLC has several advantages over pseudocapacitor, and that's the reason we use it in the conventional devices, and it is commercialized as well. So the EDLC supercapacitor consists of a porous active carbon electrode on a current collector with a separator and an electrolyte. So when a potential is applied to the electrodes, the ions in the solution accumulate at the surface of charged electrode, forming an electrical double layer. Thus, during charging, the electrolyte ions are absorbed onto the surface of charged carbon and gets dissolved back into the electrolyte solution. Since the past decade, researchers have been developing several biomass-derived activated carbon for supercapacitor application, and due to its highly recyclable and accessible across Earth. And these are categorized into plant-based, animal-based, and microorganism-based. So these resources are rich in cellulose, hemicellulose, and lignin content, which results in high yield of carbon nanomaterials. Though biomass-derived activated carbon has several advantages, it still suffers from the low energy density and several other problems. So to increase the energy density, several other techniques has to be improved, and it involves two main parameters. One is either by increasing capacitance or by increasing voltage. So this thesis focus on increasing energy density by doping strategy by enhancing the specific capacitance. So what is doping? So doping is nothing but the process of replacing of few carbon atoms or by incorporating heteroatoms into the carbon framework. So these heteroatoms causes changes in the neighboring carbon atoms, thus affecting its electronic conductivity and surface reactivity. So the doping can be achieved either by external doping that uses additional precursors and a self-doping strategy that utilizes pre-existing heteroatom content from the biomass like amine, thio-based molecules, and proteins. So moving on to my first work, it is based on the external doping strategy that utilizes ginger as a biomass source, and also it utilizes sustainable activation. Instead of KOH, we used NaCl KCl salt mixture that leaves a worm-like porous carbon nature, which is very high, which is very good in its morphology, and the thiourea doping as an external doping agent, which causes nitrogen and sulfur to be doped into the carbon framework. And the 10 here shows that the carbon nanosheets edges has highly ordered lattice fringes on the crystalline carbon, denoting that this KCl NaCl activation promotes the graphitization process, and the chemical marking shows the uniform distribution of all the elements in nature. Further, the XRD spectrum shows the two broad peaks of graphite and Raman with the characteristic P band and G band. And the BET analysis shows the specific surface area with optimized micro and mesopore nature. And the XPS analysis conforms the bonding nature of nitrogen and sulfur to the carbon framework. And the electrical performance of these samples were evaluated both in 3-electrode and a 2-electrode coin cell, which is symmetrical cell, in an aqueous electrolyte, which is 1 molar sulfuric acid. So the quasi-rectangular CV and the linear GCD curves conforms its EDLC behavior, and the doped and activated carbon sample shows a higher performance in compared to the undoped and unactivated samples. And it exhibits in a coin cell with a high specific energy of 12 watt/kg, which is higher in comparison to the reported biomass carbon. And it also exhibits 93% of retention even after 10,000 cycles. So moving on to my second work. So it is based on a self-dope strategy using oak-mud shell as a biomass precursor. The main novelty of this work is that these shells yield N-doped carbon, and in addition, SiO2 nanoparticles were embedded in the nanosheets. So the synthesis process involves decarbonization followed by KOH activation. So these shells contains 2.6% of ash content that yields carbon nanosheets with this SiO2 nanoparticles as seen in the FSM morphology. So the chemical mapping also shows the presence of nitrogen and the silicon elements in the samples. And all the samples exhibit characteristic carbon peaks, and in addition, the PET surface area shows that AOC 900 sample exhibits very high specific surface area of 3,757 meters square per gram, which is very high due to its presence of SiO2 nanoparticles and also the KOH rigorous KOH activation as a template. And the HCS spectra shows the presence of Si2P and N1S spectrum as well. And the electrochemical performance in aqueous sulfuric acid as an electrolyte, we can see that AOC 900 that has high specific surface area shows a very high performance in comparison to the other sample, exhibiting an high energy density of 12.7 watt/kg, which is higher than the 10 watt of conventional supercapacitor, and it also retained 95% of cyclic stability. So my third work is also based on the open shell, but with a synthesis strategy a bit different than the previous reported one. There it utilizes hydrothermal acidic treatment with H2SO4 to yield an sulfonated porous carbon after KOH activation. So this gave a sulfur doped porous carbon morphology where the FSM images clearly shows the porous nature of the samples and the 3D interconnected thin carbon nanosheets in the 10 images. And the XRD RAM and XPS shows the characteristic carbon peaks and also the sulfur peaks as well. So moving on to the electrochemical performance, the sulfuric acid and the neutral electrolyte were also used as a comparison where the sulfuric acid aqueous electrolyte gave energy density of 17 watt/kg, which is very high compared to the previously reported work. And the neutral electrolyte was used to widen the potential window until 1.6 volt, which gave a high energy density of 28 watt/kg. And to demonstrate its practical application, the two symmetrical cells with neutral electrolyte were connected in series, and these were able to power up different commercial LEDs like red, yellow, and green. And it can also illuminate 3.5 volt green LEDs for 5 minutes, which signifies its immense potential towards powering modern day electronics. So to summarize, I've utilized plant-based sources to obtain heteroatom doped carbon nanosheets with different doping strategies, and which can also be further scaled up to have a sustainable supercapacitor device with the increased energy density when compared to the conventional devices. So the future scope of this doped nanosheets is to scale up and to utilize or extend its application towards hybrid capacitors and battery applications. So these are from references and a few research accomplishments made so far. And I would like to first thank my parents and husband for their constant encouragement and support to achieving my dream. And I would like to thank my board supervisors for their guidance and the constant help throughout my PhD work, and the review committee members and friends and lab mates for their help. Thank you.
Hello everyone. I'm very happy to share my work with a short presentation on my thesis based on interfacial architectures using surface engineered graphene shells for hybrid energy storage. Currently, the world energy demand has grown exponentially, and the fossil fuels cannot satisfy our energy needs. Besides, the climate change, as 3/4 of our global greenhouse gas emissions come from fossil fuel combustion. So today, renewable energy sources provide a more sustainable alternative for decarbonizing. But renewable energy technologies are intermittent in nature, and the storage capacity is still limited. The stable battery technology available today is the lithium-ion battery technology. They are in our electronic gadgets, electrical automobiles, and increasingly in our energy grids, but lithium cells rely on chemical reactions to store and release energy. The electrodes are assembled in organic electrolytes separated by microperforated membrane, and when battery charges and discharge, the ions flow back and forth, and during this process, the battery gets heated up due to expansion and the contraction of the lattice. Therefore, these batteries degrade over time. Recently, supercapacitors have driven energy storage to new levels of energy efficiency. The storage capacity of the supercapacitors depends on the type of electrode materials used to gain high storage capacity. The biological materials have unique structures and the functions that inspires us for novel material synthesis. Research concerned with the biomimetics and the bio-inspired materials show important advances in copying nature's solutions to specific materials, science, and engineering problems. In this context, we have synthesized based on a biomimetic approach to develop three-dimensional dendritic cell-like nanostructures. The current progress in synthesis of carbon-based hybrid materials have resulted in various types of composites, and the major bottleneck is the restacking in the composites with no added distinctive nanostructural features. So these issues can be resolved through controlled coastal material preparations. So here in our work, we synthesize novel porous 3D carbon materials with the nanostructural features for developing a three-dimensional architectural LDH hybrid systems. So in these systems, anisotropy is one of the important considerations for the LDH hybrids, as the heterogeneous nucleation of the LDH synthesis over the conducting graphene-based core shells help avoid nanostructural aggregation and improves the charge transport phenomena in the material systems. The major challenge induced in the three-dimensional stacked interfaces can be resolved with this 3D porous nanostructures, with the charge transfers in the LDH majorly involving Faraday mechanism. However, in the hybrid systems, the charge storage is dependent on the diffusion limited surface redox reactions and the double layer component. And to give a practical application, a solid state asymmetric supercapacitor device prototypes have been fabricated, and the practical application has been implemented. We have integrated a flexible solar cell with an elastic thin film solar device with a flexible asymmetrical supercapacitor device to realize a combined energy conversion and storage system. To sum up, graphene-based designer nano hybrids in the form of dendritic cell-like morphologies have been synthesized with variant composition LDH systems, which can be connected by porous nano structures of graphene. The nano design, the tunable architecture with interconnected three-dimensional porous features help build mechanically robust materials which can tolerate high charging currents for energy storage applications. Thank you.
Hi everyone, I would like to express my sincere thanks to all the INYAS committee members and the jury board members who nominated my name for this award. I have completed my degree from IIT Monash Research Academy, a collaborative research institute between IIT Bombay and Monash University. Last year, April, I have completed my degree, and after that, I am working as a postdoctoral research fellow at Monash University, Australia. My recent research interest is safe and sustainable energy storage using tailored 2D materials. Basically, I'm focusing the 2D materials which can be derived from earth abundant resources and their applications in the next generation rechargeable battery technology. Today, I'm going to discuss about, these are the few outlines of my talk. So I will give a brief introduction, then the principle of rechargeable batteries and the selection of new materials, what are the criteria we have to follow. Then the 2D materials, whatever I have used during my PhD study, and our contribution. Also some interesting synchrotron-based in-situ characteristic techniques that I have performed in our Indian synchrotron source, and I will summarize my work. So any technology, whenever we are discussing about that, we have to first see the availability of the critical materials. So the lithium-ion battery, which is having lots of advantage, the only demerit of this technology is the abundance of these materials, and whatever materials are available in the earth crust, they are not, they are not available uniformly throughout the world. So sometimes the geopolitical issue also plays a major role. So we have to see certain kind of sustainable technology which can which can be the future energy storage technology. Now, the other concern is whenever we started using the renewable energy sources, so after 2010, this is the trend where sodium-ion battery came into the picture. Okay, so now the difference between this lithium and sodium, the abundance, the cost of carbonate also huge difference. Ocean itself a huge source of sodium. So the raw material is not a major concern. Now, this is the principle of rechargeable battery. Any battery, whenever we are dealing with like this kind of battery technology, we have to deal with the positive and negative electrodes, then electrolyte. The electrolyte in principle, it should be electronically insulator and ionically conductor. And then the comparing between this lithium and sodium, first of all, the basic difference is their difference of atomic and ionic radii. And other things like, the advantage of sodium also, you can use aluminum as both anode and cathode current collector, which is actually a beneficial strategy. Like if you use aluminum instead of copper for anode current collector, that can reduce your overall cost. So I'm not going details, but any technology, whenever we are dealing, the electrodes used, they contribute basically 50% of overall cost. So the materials, whatever we are dealing, we have to first look at the materials which can be cost effective. And using these 2D materials for energy storage applications, you can use the non-lithium metal-based rechargeable batteries due to their lots of advantages, like the overall higher electronic conductivity and the higher surface area. So these are the major points which actually helps us think of the 2D materials. Now the electrode ingredients, if you zoom any like anode or cathode, you can see first the active materials, conducting network and binder. So what happening, this is the your substrate, which is, you can say, the current collector. Then the active materials is surrounded by carbon, and the overall binder can hold the active material to the current collector. And we have chosen a new class of material, MOT2, who is having higher interlayer spacing, and which we have used as both lithium and sodium ion battery electrode. And we have prepared this material in a very low cost method and simple one-step process, a solid state route. After that, we have performed the synchrotron based XRT techniques. You can see the equal refinement of this MOT2. And we have performed the FECSM, which shows solid bar kind of morphology. And we have carried out STM experiment at Monash MCN. You can see the nice hexagonal arrangement of MOT2. After that, we have used this as a anode in lithium ion battery, because this is a new class of material. So first we thought to put this against lithium and see what are the performance it is providing. And you can see we have studied the mechanism by the synchrotron based in situ techniques. There are lots of advantages of using in situ over ex situ techniques, because you can see the DL whatever the phase change happening during the battery operations. So this is the first setup we have established, and we have carried out the experiment at industry synchrotron source, and we have filed this as Indian patent. So we are also happy to offer this setup whoever interested for carry out the in-situ battery experiments. Then this setup can be used as both in fluorescence and transmission mode of measurements. And I'm not going detail, but these are the overall schematic presentation of these setups. Then we have performed the GEN study. GEN is interesting because it is elemental specific, and you can find out the information about the oxidation state and the nearest neighbor information and so on. So we have done this in situ GEN study for MOT2 against lithium metal, and we have whatever you can see from the in situ GENs during discharge, the oxidation state is like the energy shifted from higher to lower. That means the oxidation state of MO, this is MO GENs, is decreased, and during charging the reverse happens, which is supported by our SAD pattern of TM and also the DFT study. So after means all these characterization technique, this is the mechanism we have finalized. So during redox reaction, this is the mechanism following, and during the discharge and charge, these are the phase form happening, and the material is getting back to its original phase. So after this, we have used this in a full cell configuration, and the overall cell voltage of this cell, we got nearly 2.1 volt, and this can perform nearly 100 cycles with a specific capacity of 220 against LCO as cathode. After that, we have used this material against sodium. You can see at sodium, when it is used as anode, it performs very nicely at high current rate. And this is the full cell configuration, which provide a nominal voltage of 2 volt and specific capacity of nearly 207 milliampere hour per gram after 150 cycles. So the mechanism also we have studied through synchrotron based excitant characterization techniques. I have not discussed here. And this is the comparison study of our full cell and other available full cell studies, which you can see. Like if you can see the Faradian, which is actually now the Reliance is planning to establish in India, it is comparatively, it is close to that energy density, but here we have only in the coin cell level, and we have considered the weight of anode material for calculation of our energy density. We have filed this as Indian patent, and also this work also published in Nano Energy paper. This is the overall reaction mechanism which is followed by this material against lithium and sodium. So the other work what I have additionally performed during my PhD is the bioderived carbon. We have used for this as lychee seed, which is a waste basically. From the waste we have prepared the carbon, and which give a very good performance in both half cell and full cell configuration. Another also one source of biocarbon, which is basically your Tamarindus indica plant seeds, and that also performed very well in both half cell and full cell configurations. You can see a single coin cell is able to lamp and LED light. So these are the outcomes of my research. I have filed 5 patents, 2 of them are granted and 3 are under review now. So these are the awards that I have received during my PhD study, and these are few publications as fast authors, and few are the contribution of my expertise I have used as a co-author papers, and these are the conference proceedings, and this new XRT pattern we have filed as a database. And I want to thank to my research lab group from IIT Bombay and Monash University. I want to thank our collaborators and the professors from both IITB and Monash universities, and thank you the INYAS members and all participants for your time. Thank you, everyone.
Hi, everyone. I sincerely thank the Indian National Young Academy of Sciences for selecting me to receive the prestigious Sir John Mason Thesis Award for Interdisciplinary Research. It's a very encouraging and proud moment for my team and me for this acknowledgement and recognition of our work by the first and only recognized Young Scientist Academy of India. In this venture, I'm delighted to share with you all about my research briefly. My thesis titling, Spatiotemporal Variability of Atmospheric Carbon Dioxide over India and Design of Optimal Monitoring Network using Observations and Lagrangian Modeling. So I have pursued my PhD from Space Physics Laboratory under the guidance of Dr. Radhika Ramachandran. Currently, I'm working as a postdoctoral researcher at the University of Oklahoma. So we are very much aware of climate change and how it impacts our existence on the Earth. We see catastrophic extreme events worldwide associated with the increase in global temperature. It's a perfect time we should act on it to hand over the Earth in livable condition to the future generations. So our team, Numeric Atmosphere Modeling from Space Physics Laboratory, has initiated the greenhouse gas studies in 2014 as part of the National Carbon Project. My study is formulated based on the impact of greenhouse gases, especially large quantities of CO2 on the atmosphere, one of the primary factors controlling the atmospheric temperature. My study focuses on the Indian subcontinent having unique climatic patterns and heterogeneous biodiversity. It's sad but true that there is only very little documentation or monitoring of atmospheric CO2 as far as India is concerned. This calls for coordinated efforts to estimate CO2 emissions in the country on a larger scale, which would be an important input to the policy formulators apart from scientific merit. I have done my work in 3 parts using different resources available. So I've utilized all available platforms like observations from satellites, in situ, and model simulations to characterize CO2 over India and identified some major gap areas, including the limitation of satellites to monitor CO2 over India during the monsoon season, despite its large spatial and temporal resolution. During this period, we need to depend on the other in-situ measurements. However, my study also identified the uncertainty in the CO2 concentration estimation by models results from the lack of comprehensive observation network and its importance. Observations are important,
But where you collect the measurements is much more important if you want to extract maximum information from them. Based on this motivation, I formulated my second study to propose an optimal network of ground-based CO2 observations through one of the well-established methodologies known as Bayesian inversion uncertainty analysis, along with the incremental optimization methodology. Though it was computationally challenging in terms of available resources, I could successfully propose a ground-based observation network for India. That's for the first time. That will be a good input to the CO2 flux estimation problem. Though I could not establish the network in practice during my research period, it has become a good reference to the groups who are coming up with their ideas and instruments. Then I moved on to test whether the observations are really add-on to the flux estimation problem by taking an example. Here I applied Bayesian inversion over India, utilizing observations from Srinagar in Western Ghat region maintained by Indian Institute of Tropical Meteorology, Pune. The results were surprising to see that single station could provide information that was not already reported in the inventories. Obviously, this is not the end of it. I expect to see different groups coming up with the flux estimation over India by rectifying the caveats in my work. I thank my parents' organization, Space Physics Laboratory, and Indian Institute of Tropical Meteorology for all their support and making me who I am today. And my research supervisor, Dr. Radhika Ramachandran, for giving me the opportunity to work in this field, which was started at the time I joined for PhD. I thank you all again. Stay safe.
Hello, everyone. I am Nitish Nayak, a recently graduated PhD scholar from Indian Institute of Technology, Madras. My thesis was on formulation of printable inks of silver nanowires for flexible device applications. My research was basically on a special kind of materials called transparent conductors, and as the name implies, they are optically transparent and electrically conducting. It is the same material present in our mobile phone as top electrode of the displays and also for making the touch panel on top. The commercially popular indium tin oxide is very expensive because of the indium present is a rare element. It is a ceramic and hence not suitable for flexible applications, and complex paper deposition techniques are required for fabrication. Clearly, a substitute is needed for ITO. And if you think of a substitute, silver nanowire is a material whose performance lies much closer to IT. Silver, being a metal, is highly conducting, and because of its low surface coverage, the light can pass through these gaps very easily, and hence it appears to be transparent. Because of the wire light structure, they are highly flexible, and we can deposit it over even paper at relatively low temperature. The formulated ink, by optimizing the rheological properties and dimensions of the nanowires, and deposited using a direct writer printer that we customly built by the students. So such a printed film shows a high transmittance of about 90% and sheet resistance of 30 ohm per square. The performance is much better compared to an indium tin oxide that's deposited on a flexible substrate. The film shows excellent flexibility, which is confirmed here. You can see as even I twist or roll the film, the intensity of the light remains same, confirm that the resistance of the film is not much varying with flexing. So such a material has wide range of applications. Here I implemented a flexible and transparent heater. You can see here a water droplet is evaporating with time. So such heaters we can use for therapeutic applications as wearable heaters and also for anti-fogging applications. Another potential application is actually for transparent Wi-Fi antennas. So here we can replace such a rigid and long antennas with such transparent and flexible antennas without visually get noticed. I also implemented a photo detector by making a composite of nanowires and zinc oxide. So basically the zinc oxide will absorb light and produce photocarriers. These carriers will modulate the current through the nanowires and we can use to detect light. So they are also transparent and highly flexible. Another application is for making transparent and flexible touch sensors. You can see here, based on the position I am touching, a LED is glowing to show the response. The same touch sensor is working fine under bend conditions and also support multiple touch. Basically, the electrodes are printed using nanowires. In between, electric field will be present. And when we touch, some of these fields will be absorbed, results in a fraction capacitance that can be used to sense the touch. The conventional approach is to implement touch and display as separate layers. What I did next is I tried to combine both these functionalities into a single material by formulating a nanocomposite of thermochromic materials with nanowires. Thermochromic materials that change its color with temperature. So when a voltage is applied to such a material, high current will flow through the nanowires, results in Joule's heating, and the thermochromic material will absorb this temperature to change its color. So you can see in this video, when I apply voltage, the color of the material is changing. So I made a printable ink with this material to fabricate a display. This is actually a 7-segment display used to represent numbers. And you can see also in this video that when I remove the voltage, it is coming back to its initial color. Since nanowires are present in a matrix, the same material can be used to implement a touch sensor by adding some extra circuits. So this is actually a matrix of display segments. And you can see as I touch on top of the display, it detects the touch and also changing its color, which means the same material can function both the functionalities. So such a material can be used to implement wide variety of display applications. With that, I would like to summarize my work, which is basically on formulation of printable inks stitched of nanowires for a wide variety of flexible applications that has huge demand and also can be used for the benefit of the society. Finally, I would like to thank Indian National Young Academy of Science and INSA Nanotechnology for giving me this opportunity. And also, I am really honored to receive the Excellence in Nano Innovation Award. Thank you.
First of all, thank you INYAS family for selecting me for National Award for Research Excellence Best PhD thesis in the area of electrochemistry. I am Dr. Sahil Reza. I have recently completed my PhD from Indian Institute of Technology, Roorkee, on synthesis of nitrogen dope reduced graphene oxide-based material as electrodes and the analysis of the role of different aqueous electrolytes. As we know, the most important energy storage devices are batteries, sourcer, and supercapacitor. The importance of these devices can also be understood as a Nobel Prize for Chemistry has been awarded to these three finalists for their groundbreaking research on lithium-ion battery. Our batteries have some limitations, like reduced power density and long-term cyclic stability. For that, supercapacitor can be an alternative. As you can see, supercapacitor bridging between the batteries and conventional capacitor. The present focus of scientific community is to somehow increase the energy density while not compromising its power density. To achieve this, we need to develop efficient electrode and electrolytes, which can provide high capacitance and be stable for high cell voltage. When we compare the electrolytes, as we know, the commercial devices are using organic-based electrolytes because they can provide high cell voltage. However, disadvantages of organic electrolytes poses a major concern for the future process. On the other hand, aqueous electrolytes have these advantages. However, it is limited toward the potential window because of water decomposition. So the major objective of my PhD was to develop efficient electrode material and to study different aqueous electrolytes to understand their fundamental as well as applied aspects to develop high cell voltage aqueous electrolyte-based supercapacitor devices. Now let me take you to the journey that how we achieved this aim during my PhD. First of all, we have synthesized an efficient nitrogen dope reduced graphene oxide from graphene oxide through a very simple low-cost scalable process in which graphene oxide has been significantly reduced and nitrogen has been doped in its structure simultaneously, which has been characterized extensively. We confirm that we have a material which is highly conductive and have appropriate micro-mesopores in structure, including ultra-micropores, which is going to be very beneficial for our electrochemical study. Then we explore electrolyte area. First, we explore electrolytes depending on pH. As we can see in acidic pH, the potential window is limited toward the negative potential side, and in basic pH, the potential window is limited toward the positive potential side. However, in neutral electrolyte, we were able to enhance the potential window in both negative and positive direction. To understand this thing, we have worked out the mechanism. As we can see, at very first cycle, HER and OER originate at very early potential, but when we increase cycle number, the stability of potential window is getting increased. It can be understood as a nascent hydrogen, which was combining to produce HER at very early cycle. Now they are storing in the ultra micropores of the electrode material, which inhibiting the HER activity and increase the stability of potential window. The more details can be found in our publication. Then we further wanted to explore electrolyte area. For that, we have explored water and salt electrolyte. Water and salt electrolyte very essentially introduced electrolyte where the salt concentration exceeds the water molecule, both by weight and volume. A number of investigations have been focused on lithium PFSA research. However, its commercial application might be limited because of its higher cost, poor connectivity, and low bundle. Therefore, there was need to develop some other alternative. For that, we have firstly worked out with sodium perchlorate. As we can see, that when we increase the concentration of sodium perchlorate electrolyte, we are getting the stabilizing the potential window further in both directions. This can to understand this, we have worked out the characterization of electrolyte from 1S NMR FTS spectroscopy. From this, we have confirmed that acetate-based anion is a water structure breaking anion, which breaks the hydrogen bonding network of water structure. And when we increase the concentration of electrolytes, its effect is increasing, which helps to strengthen the OH bond of a particular water molecule. That means it is difficult to dissociate that particular bond, which helps to increase the potential window stability when we increase the concentration. Then we have designed a symmetric supercapacitor in this electrolyte, where we have achieved the cell voltage of 2.7 volts, which is much comparable to the organic electrolyte-based supercapacitor devices commercially available. Then we further want to explore water infused electrolyte. Surprisingly, we have found that even with very high concentration of 27 molar, acetate-based salt symmetric supercapacitor only provides a cell voltage of 2 volts, whereas nitrate-based salt only provides 2.3 volts of cell voltage stability. To understand this, we have characterized for 1S NMR ATO spectroscopy, and we found that acetate-based anions are not water structure breaking anions. They don't influence the hydrogen bonding network of water structure. Therefore, we have achieved less cell voltage stability in the acetate, while nitrate is intermediating between the acetate and the perchlorate ion. So, in the conclusion, I would like to say that we have worked out a fundamental as well as applied understanding to develop for high cell voltage aqueous electrolyte-based supercapacitor devices, which is much comparable to commercial available organic electrolyte-based supercapacitor devices. I would like to acknowledge my supervisor, Professor Anil Kumar, for his invaluable guidance. A special thank you to INYAS family, selection committee for believing on our work and selecting me for this award. Thank you for all of you, your kind attention.
Hello everyone, myself Shikha Khandilwal. The title of my presentation is Bio-Inspired Catalyst Design Strategies for Activating Dormant Transition Metal Cores for Hydrogen Evolution. Energy is a very important commodity in the world. More than 80% of our energy coming from the fossil fuels. During the energy extraction process, we produce a lot of carbon dioxide. Carbon dioxide is a greenhouse gas and has adverse effect on the environment. Renewable energy resources are the best alternative to fossil fuels, but due to their intermittent nature, we cannot use them directly. So we need a system to store renewable energy resources. Taking inspiration from natural photosynthesis process, scientists are trying to store solar energy into the chemical energy, and that stored chemical energy can be used when required. This model is called artificial photosynthesis model. In my thesis, I'm trying to develop catalyst for hydrogen production reaction, and that required 2 protons and 2 electrons. We have decided to work with cobalt saline core, as this core is not active towards electrocatalytic hydrogen evolution. We have incorporated enzyme-inspired features into the core using 2 natural amino acids, that is tyrosine and phenylalanine. We have also prepared the control for both the complexes, that is tyramine and benzylamine. During the electrochemical investigation of cobalt saline tyrosine complex, we observed 3 significant observations. First, as the pH of the system decreases, the 2-step 1 electron reduction of cobalt 3 to 2 and cobalt 2 to 1 changes into a single step 2 electron reduction, that is cobalt 3 to 1, because of the PCET mechanism. In the second observation is, we observe hydrogen production catalysis only below pH 4, which is confirmed by the GC. The third question we have here is, why we are seeing catalytic signal only below pH 4? Is there any involvement of functional group? To understand that, we have to understand the mechanism of hydrogen production. In the catalytic cycle, cobalt 3 is reduced to cobalt 2 and further reduced to cobalt 1. At the cobalt 1 stage, proton will bind and form cobalt 3 hydride. The hydride combined with the proton and form hydrogen, while cobalt 3 regenerates. In this catalytic cycle, proton binding to the cobalt is the key step for the catalysis. The pH titration study of cobalt saline tyrosine complex showed the pK of carboxylic acid is around 4 and phenolic group is around 11. That suggests the carboxylic group is responsible for the pH dependent catalysis. How the carboxylic acid is controlling the catalysis, we can understand from this diagram. When the pH of the system is greater than 4, at that time carboxylic acid will become carboxylate and it bind to the cobalt, where proton cannot bind because the proton binding site is occupied since there is no catalysis in higher pH. While when pH is less than 4, the carboxylate become carboxylic acid and the proton binding site is available. Hence the catalysis occur only below pH 4. We have prepared 4 complexes, cobalt-silane tyrosine, where we have carboxylic acid and phenolic group both. Second, phenylalanine complex, where we have only carboxylic acid group. Cobalt-silane tyramine complex, where we have only phenolic group. Cobalt-silane benzylamine complex, where we do not have carboxylic acid or the phenolic group. Hydrogen production is observed in the complexes where we have carboxylic acid or phenolic functional group. That is, we do not see any hydrogen production in the benzylamine complex. While the pH switch, that is pH dependent catalysis, is only observed where we have carboxylic acid group, that is in tyrosine and in phenylalanine. In conclusion, we can say these functionalities are very important during the catalyst design. They can activate the inactive core towards the hydrogen production. And thank you. I would like to thank the Indian National Young Academy of Sciences and my supervisor, Dr. Arnab.
Thank you and congratulations to all winners.
Thank you. Congratulations to all winners, and really nice to listen to their work. The next item in today's program is the release of INYAS newsletter in vernacular languages. I request our member, Dr. Praveen Kumar, to say a few words about this newsletter.
Thank you, Dr. Rajni. It is indeed a great pleasure for me to brief all about the INYAS annual newsletter. Having an annual newsletter rich with many societal activities throughout the year is always proud of an academy. Particularly we INYAS as the Young Academy of India. I'll go a little bit superficially because we have a lot of activities and I have only 2 minutes to explain it. So we INYAS has covered a wide range of topics in our last year's activity for public awareness, scientific discussion, even in the COVID pandemic situation. Few of them I can list here, like example, we had a COVID-19 awareness where we have a series of talks with the experts to educate our society about COVID-19. So to keep them aware of actual facts and findings. We had a series of webinars on different topics throughout the year. I can name a few of them here, which has engrossed huge participation. Like INSA-INYAS Vigyan Setu, Gyan Tika, Miles to Go, what do we do next, where weekend webinars, we had a popular science talks, scientists from India past and present, Let's Talk Science Series 2.0. These are a few of them. Further to add all these, INYAS has published 2 white papers, and both white papers have taken massive attention from the distinguished scientists, authorities and administration. The first white paper was on the fostering curiosity-driven fundamental research in India, whereas second white paper we have published on the need of tenure extension of India's PhD students. We as INYAS has edited the proceeding of INSA, P-INSA, issued published by Springer. We have also edited an INYAS special issue of Resonance. It was an immense pleasure for me to be editor of this INYAS newsletter. So I'm thankful to my co-editor, Dr. Prashant and Dr. Dijwinder, and all my friends who have helped me or who have helped us to translate into 8 other regional languages. I'm also thankful to Dr. Chandra, former chair INYAS, and all the core committee members, particularly to Dr. Rohini for providing all the informative supports to make this newsletter rich in content. Thank you once again. Now I'll hand over this to
Thank you, Praveen. I now invite Professor Devang Kakkar, Vice President of INSA, to release the newsletter.
No. Let me try again.
No. Hard disk is separate. Data management, yes. Yeah. So here it was 140 separate. Yeah. Because I don't want to now go and clarify to them what have you budgeted. I am assuming that 50,000 for other data management.
So this is the one?
Yes.
Yes, sir, but we have to download, otherwise it will okay, display.
This?
Yeah, no, it's fine. Yes. You can just continue. Yes.
Is this okay?
Yes.
No, 240 total. This was. Oh, sorry, that is saying 3 annual. Oh, no, that's in.
Is this what you wanted me to show?
Thank you, sir.
Okay.
Thank you very much, sir. I now invite Professor Kakkar to deliver his address.
Okay. So good morning, and let me wish everyone on this very nice occasion of Science Day. All of you are scientists listening, and I wish you great success in all your endeavors. My congratulations to all those who received awards for their PhD work. I didn't listen to all the talks, but I listened to several of them, and really they were all very interesting, the ones that I heard. It clearly shows that the kind of work that is going on is of a high standard, and INYAS is doing a lot of nice work to encourage better science in the country. Let me also congratulate all members of INYAS for their efforts in promoting science in the country. We already saw in the last GBM a lot of praise from the principal scientific advisor on the work that you're doing and the importance that it has. So on this occasion, let me also I thought that I will just make a very brief presentation just to highlight some of the things that in the recent past that I have found quite interesting. And so, it's a short presentation. Please let me know if you can see it. Is it visible?
Yes, sir. Yes, sir. Yes.
So, just to start with what we are actually celebrating. We are actually celebrating the discovery of the Raman effect, but also we are celebrating Professor C.V. Raman. He saw what everyone else saw, that the sky is blue, but he had a deep enough knowledge of physics to understand and explain why this happens, and he was the first person to do this. But not only that, he understood the theory behind it, but he also built this apparatus to validate his theory. And he did this when there were no funding agencies available for support to actually purchase the components that went into building this. So apparently he was supported by a private businessman. And of course, he was very successful in doing this, and he was recognized internationally by the Nobel Prize once he announced his discovery. Today, Raman spectroscopes are everywhere. It took a long time for these spectroscopes to develop, and they have gone from being scientific instruments where people are using Raman spectroscopes to analyze their samples that they have produced, to now they are being used almost on a common basis. And when you go to the airport, you see they take those little swabs and put them into Raman spectroscopes. So, you have hundreds of them in all the airports and so forth. And now they've become a very commonplace instrument for analysis. So, it's remarkable that he could do this in 1928. Though he was working in Calcutta University, there was not much research possible in the university itself. And we are lucky that there was a private citizen, Dr. Ashutosh Mukherjee, who had started this organization called the Indian Association for the Cultivation of Science, which was encouraging research in science. And Professor C.V. Raman, while teaching at Calcutta University, was also associated with this institution. And it was a small institution, but promoted research, and he was able to pursue his work. When you look from there to today, progression has been amazing. And even though India is still a poor country, throughout our history post-independence, science has received a lot of support. We have had more and more institutions growing. We have had, increased funding in research. We've had support of big science and all kinds of things. And today, India has grown to be a major scientific power. And of course, it has a huge impact. And, when I look back and see, the COVID pandemic, India was one of the few countries in the world where we actually could, get the vaccine because it was being made here. Almost all of Africa was just waiting because all countries had essentially put an embargo on exports. So, certainly this is just one example of how our investment in science is paying off. And, there is great science being done at all levels, whether it is through the mission-oriented organizations like ISRO, and we heard from Dr. Kiran Kumar today, or BARC, and many other, DRDO, who are doing very applied and specific research trying to develop technologies, to work being done in the universities and research institutions all across the country. And those are making an impact on the international stage. Really, I think that this kind of support for science, this enthusiasm for science, has a big impact, not just on the prosperity of the nation, but just in the way that we approach things, in the way that we try and solve problems, and even the way that we govern. And so I think it has been a great positive for our nation, and I'm really grateful that the leaders over our long history have given so much support to science. Before, ending this address, I thought I would just highlight 4 things that I have come across in the recent past. Because you always think, what is there left to discover? And, they're just breakthroughs that are happening. And I picked out 4 things that I would just like to bring to your attention. I'm sure each of you can come up with some others which are equally or even more interesting. But I thought I'd just bring 4 things to the notice of all of you. One is that, the James Webb Telescope has been launched. This was launched on the 25th of December 2021, and it has reached at the Lagrange point about 1,000,000 kilometers from the Earth. And this is just an amazing instrument. It has been in the works for more than 20 years. People have been thinking about it, trying to develop the technologies to go into it. And now that it was finally built, the cost of the project has been something like $10 billion. It's a really big science project, but it's an amazing project. I have been keeping track of, almost every other day I go and look at the website to see what is the progress on this. So, this is actually an infrared telescope, an amazingly sensitive infrared telescope, which will allow us to look at the most distant galaxies, which is basically saying that we want to look back in time about, maybe even just a few million years. I don't know how close they'll come to the Big Bang, but the whole idea is they want to look at the first galaxies being formed. And, when you're looking far back, you're also looking far back in time. And because the universe has expanded over the last 13 billion years, so all the light that came out, even though it was in the visible spectrum when it first left the galaxies, now after so many years of expansion of the universe, everything is in the infrared spectrum. So this is an infrared telescope, and an amazing one. They have now been able to, they're sitting and essentially trying to focus these 18 segments of the mirrors, and they very successfully managed to focus each one of them so that a single star produces a nice focused image from each one of them. And really looking forward to this. So not only will they look at the first galaxies that were when they were formed, but it is sensitive enough to even look at planets which are in nearby stars and determine what their atmosphere is like and so forth. So this is one of the really great things to look forward to. And even though I don't work in the area, I'm very enthusiastic about this because it's a real feat of technology, which is going to produce a lot of new science in the years to come. The second thing that, is also big science, and which I think is a really major development, is that there is this joint European torus, which has produced 59 megajoules of energy and has stayed lit for 5 seconds. So this is really another, I feel, a milestone in the development of fusion energy. And again, something really to look forward to. And I can see that, this is really moving forward. ITER will, of course, is something that even India is participating in. And I'm sure that with these developments, we are going to move forward. There's, of course, though a huge amount of power has been generated, the power ratio is still only about a third. That means 3 times more power went in than the amount that came out. So still some way to go, but to reach Q1. But still, I feel this is a major step forward, and a lot of science technology has gone in to reaching this stage, and I'm sure a lot more will go in the years to come. The third thing that I felt quite excited about was that, it's been now almost 40 years since HIV was first identified. And in the 80s, the virus was identified. But now through stem cell treatment, it appears that a cure is in sight. And I think this is a really major development. And And I think that, if it works for HIV, I think that this could open up many more treatments for other viruses. And, now we're already suffering from one novel virus, but who knows, even this may be, and there's the HPV virus also there is, which, we can probably deal with. And the final thing that I'd like to talk about is much smaller in terms of science, but it's something that is, something that I felt very excited about because it's close to the areas that I work in. And, so we've been making lots of 2D materials, but this recent work, which came out just in February of 2022, is an amazing new polymer. So in the 70s, Stephanie Kwolek and others at DuPont invented the para-aramids. These are rod-like polymers, very stiff polymers where they take on a rod-like shape, and they can be spun into fibers which are ultra strong, the Kevlar fibers, which we now know that they've been used for years now, since the 70s, in making bulletproof vests and so forth. Using exactly the same chemistry as this, these authors have actually produced sheets of polymer. What is remarkable is that this material is solution processable. It has a yield strength which is twice that of steel, though the density is 1/6. It has modulus that is 4 times that of polycarbonate, which is used for as a replacement for bulletproof glass. And what is remarkable that it has a permeability that is 22 times lower than typical polymer barriers that are being used. So this is a really remarkable thing that this kind of development is taking place in an area which seemed to be quite mature, but they've come up with some really wonderful chemistry, and it looks like this could be a major development in the field of materials. So with that, as a very brief sort of digression into some recent developments that I personally found interesting, let me wish all of you again on the National Science Day, and all the best for all your endeavors.
Thank you very much, Professor Kakkar. Thank you very much for your address, which looked at why we are celebrating this day and what has been the spirit behind the Raman's discovery and its impact over the years, and also for picking out the 3 issues which you think is it's currently great scientific endeavors. Thank you very much for your inspiring words. Now we have come towards the end of today's program. I request Dr. Chandramohan Nautiyal from INSA for presenting formal vote of thanks for this joint program celebrating Science Day, National Science Day. Sir, you're muted. Could you please unmute?
Thank you for giving the most interesting and pleasant assignment to me. That is thanking the wonderful people who have made this program possible. We are very thankful to Dr. S Kiran Kumar, the former chairman of ISRO, and now the Vikram Sarabhai professor. He took us on a beautiful journey from the early days when the negotiating with science and technology was as important as negotiating with the fishermen. He told us how the technology in space has grown, and the space for space is now really growing, and we have reached the present state where the Indian Space Research Organization has become a model for success for any technology that is new. We are thankful to you, sir, for bringing this excitement of space science to us. We are thankful to Professor Chandrima Shaha, the president of Indian National Science Academy, and also the J.C. Bose Distinguished a professor at IISb Kolkata from the National Academy of Sciences. She told us how beautiful the process of science is. And if we really want the people to get excited and appreciate science, then it's important to tell also about the intricacies of the process as much as of the product. Thank you, Professor Shah. And also as the president of INSA, who has always been very supporting of the INYAS efforts. We heard Professor Devang Khakar, Vice President of INSA, former Director of Indian Institute of Technology, Bombay. Professor Khakar, I have never seen him in this role, but today he, just with 4 or 5 slides, he made a beautiful presentations of the 4 most exciting works of science and technology in the last few years. And we are really thankful to you, Professor Khakar, for bringing this excitement to us. And we feel that this, who are young members of INYAS, and some of them just who are no more that young, that they will appreciate the intricacies of these things and also have some interest developed outside their specialized field of area, as Professor Khakar just showed. We are thankful to Dr. Rajendra Singh Dhaka, the present chair of INYAS, for making this program feasible. And of course, to Dr. Chandrasekhar Sharma, the former chair, and also one who coordinated the efforts for the awards for the young scientists this year. We are also thankful to Dr. Seema Mandal of the Indian National Science Academy and Ms. Madhvi of INYAS, and all the staff members of INSA and INYAS, and also all the committee members of the awards committee and the team which brought out this beautiful newspaper. So thanking you all again at the end. Also the audience who made this effort worth it. I'm sure that many more would be watching it on the YouTube. So we thank them on behalf of INSA and INYAS both. And again, once again, congratulating you and giving our best wishes on this day of the National Science Day. Thank you so much. Over to you.
Thank you very much, Dr. Natia, for the vote of thanks. I now request all of you to rise for national anthem. I thank one and all for participating in this INYAS INSA joint event for celebrating National Science Day. Really nice. We had a very nice gathering today, and I congratulate all the winners of INYAS Awards. Thank you very much.
Madhvi, we can stop the live streaming.